All right. EEE203 practice midterm problem number 7. Compute the Fourier series coefficients of the periodic signal x of t equals 1 plus cosine t sine 2t. And then over here on the right, from the handout we have, from the handout Dr. Wang provided, if x of t is periodic with fundamental period t sub naught is equal to 2 pi divided by omega sub naught, then x of t is equal to this summation. Be represented as this summation, and that the Fourier coefficients, AK, in here are represented, are equal to this formula, this complicated looking formula. That's really, it is kind of scary looking, but it's pretty simple. But we don't need this one, for this problem. Don't need for this problem. Let's look at our let's look at our two periodic terms right here. We have that a cosine of t, let's say that's equal to cosine of omega sub naught, or let's do omega sub 1 of t. Then omega sub 1 is equal to 1, and that's equal to 2 pi over t sub 1. So that means that t sub 1 is equal to 2 pi. And sine 2 pi, or excuse me, 2t is equal to sine of omega sub 2 of t. Then omega sub 2 is equal to 2, and that's equal to 2 pi over t sub 2. And t sub 2 is going to be equal to, well, 2 multiply that over, and then we get 2 pi divided by 2, so we get pi. Now, t sub 1 is a integer multiple of t sub 2. So our fundamental period is 2 pi, and fundamental frequency, omega sub naught, is equal to 2 pi divided by t sub naught, which is equal to 2 pi divided by 2 pi, which is equal to 1. All right, so we've identified this. Now let's rewrite x of t in terms of complex exponentials by applying Euler's identity and Euler's formula. And if you don't know that yet, then just go play around with it until you're comfortable with it off the top of your head, because it'll pay off in the long run. But so we have that cosine of t, that's equal to 1 over 2 e to the j t plus e to the negative j t, and that's multiplied by 1 over j times 2. Let's do 2j, and that's multiplied by e to the j 2t minus e to the negative j 2t. And if we pull out the coefficients, or if we pull out 1 over 2 and 1 over 2j, we get that x of t is equal to 1 over j 4. And now we have to do some multiplication. We get e to the jt times e to the j 2t, so that's e to the j 3t minus e to the jt times e to the negative j 2t. So that's going to be e to the negative j t, right? Negative 2 plus 1, yep. And then plus e to the, we have this one multiplying it right here, negative jt times e to the j2t, so that's going to be e to the jt, and then we want to multiply this one to here, so we have another minus sign, and we get e to the negative j3t. And kind of out of order here, I like to go from negative to from the most negative to most positive. So then we end up with x of t is equal to 1 plus 1 over j4 negative e negative j3t minus e to negative jt plus e to the jt plus e to the j3t. And our fundamental frequency is 1, right? So if we compare that with our summation up there, a k e to the j k omega t, and we know that omega sub naught is equal to 1, then we get e k or excuse me, capital sigma from k equals negative infinity to infinity, a k e to the j k t. Well, now it's pretty clear. So we have this k right here. Well, here's a k. There's a 1 in here. So that's a k. There's a 1 right here. That's a k. And this is a k. So we have this is k equals 0 right here, because 1 is equal to e to the j 0. And then this is k equals negative 3. This is k equals negative 1. This is k equals 1. This is k equals 3. So then our Fourier coefficients are a sub 0 is equal to 1. A sub negative 3. And here's our negative 3, so we have a negative term, and this we have a negative. Let me go to highlighter real quick. We have a negative sign, and we have this coefficient right here. And if we look at case of 1, well, we have the same coefficient. We have a negative sign, so then we get a negative 3 is equal to a negative 1, and that's equal to negative 1 over j to the 4th. And you could rewrite that if you wanted to as j to the 4th. And that's because negative 1 over j is equal to negative j over 1, which is equal to j. And then for our Fourier coefficients of a1, well, that's going to be equal to a3 with the positive sign right here, the positive sign right here, and that same coefficient up front. So we get 1 over j to the 4th, and I wouldn't rewrite it like this, but you could, and that'd be j over 4. All right. I'll be back with the next problem.